Building mathematical models, cost, revenue, and profit. The price of a cup of ice blended coffee is $6 at a certain coffee shop. It costs $1.50 to make each cup of coffee and $100 per day to run the business. Part A. Find the total cost function C of x for a day of production, where x represents the number of cups of coffee produced. Let's recall the pieces of total cost. Total cost is equal to fixed costs plus variable costs. So total cost, we are told to call that C of x, where x is the number of cups of coffee produced. So C of x is equal to, fixed costs are not dependent upon x, the number of coffee produced. Fixed costs is just no matter what, we have to pay that amount. So in this problem statement, we know that $100 per day is the amount that has to be paid to run the business no matter what. No matter how many cups of coffee we produce, we have to pay $100 per day. So the fixed cost is $100 plus now the variable cost is dependent upon the number of cups of coffee produced. So it costs $1.50 to make each cup of coffee, and I'm making X cups of coffee. So we're going to multiply $1.50. Well, since I'm removing the units of dollars, I'm going to go ahead and put 1.5 times X. So our cost function is 100 plus 1.5 times X, which notice is a linear function. I can rewrite this as 100 plus the fraction 3/2 x if I choose, and I can even rewrite it where 3/2 x is first plus 100, the constant is second, to really try to notice that this is a linear function in the form y equals mx plus b. Now for part B, we want to find the total revenue function R of x for a day of sales, where x represents the number of cups of coffee sold. Okay, so the revenue function, R of x, is going to be equal to the price of a cup of coffee, which we see in the problem statement is $6, times the number of cups of coffee sold. So revenue is also dependent on the number of cups of coffee sold in this case. So R of x is 6 times x. For part C, we want to find the total profit function P of x for a day of making and selling X cups of coffee. Let's recall the formula for total profit. Well, total profit is equal to total revenue minus total cost. So total profit, we're going to call P of x. We found total revenue in part B, which was R of x, and we found total cost in part A, which was C of x. So let's go ahead and substitute in those functions. R of x was 6 times x minus the cost function was 3/2 x plus 100. I'm making sure to keep that in parentheses because this negative will distribute. So now let's go ahead and distribute the negative. So we have 6x minus 3/2 x minus 100. Now 6x minus 3/2 x are like terms. So we would subtract 6 minus 3/2, or it might be more helpful to remember that 3/2 was 1.5. So 6 minus 1.5 is 4.5 x minus 100. So the total profit function, P of x, is 4.5 x minus 100. Finally, in part D, we're asked, will this coffee shop return a profit if they sell 300 cups of coffee each day? Well, the whole point of building a mathematical model is to use it to calculate different things about the product. So here we know that our profit function from the previous part was equal to 4.5 x minus 100, where x is the number of cups of coffees produced and sold. So here we're told that we're going to sell 300 cups of coffee and see what happens. So we're going to substitute 300 into x. So we have 4.5 times 300 minus 100. 4.5 times 300 is 1,350 minus 100, that's 1,250. So the answer is, will this coffee shop return a profit? And the answer is yes. They will make $1,250 every day if they sell 300 cups of coffee each day. So since that is a positive value, yes, this coffee shop will return a profit.